You didn't mail me reprints in a manila envelope.
That's right.
I refuse to speak to you.
That's right. I hate snakes, Dan. I hate them.
Welcome to Hello PhD, a podcast for scientists and the people who love them. This week, we wonder how specific your research interests need to be when choosing a graduate program and a lab. Stay with us.
And we're back. This is Hello PhD, episode 76. I'm Joshua Hall.
And I'm Daniel Arneman.
And we'll discuss the human side of science and life in the lab. Dan, it's our birthday.
Yeah, 2 years old. We're toddling.
Yeah, our first episode, actually, I didn't realize this. You alerted me to the fact that we released episode 1 on July 9th, 2015.
It was so long ago. It feels like a long time ago.
It does. 2 years. Wow.
2 years, 76 episodes, did you just say?
76 episodes.
Still cranking them out. Still getting together and still starting the same way we always do.
That's right, with ethanol. But since it's our birthday, I broke out the good stuff.
What do you have for me?
All right, so we're going to deviate from our normal beer drinking, which I guess will make some people happy. If you're not a beer drinker at all, you probably wish we'd do something else.
That's right. Did you just take my glass?
Oh, is that your glass?
Yes, put it down. Put it down.
Sorry, I touched the rim of it too. Sorry. All right, so we are having this week one of my favorite bourbons.
Okay, what is it?
This is Blanton's Single Barrel Bourbon Whiskey from Frankfort, Kentucky, distilled at the Buffalo Trace Distillery.
I've been to Frankfurt, I believe.
Have you? Oh, yeah.
I went to University of Kentucky for undergrad.
Right.
So
that's on my bucket list, actually, is to do the bourbon trail there.
Oh, it would be fun.
Kentucky.
Let's do it, yeah.
We should. So anyway, this is currently my number one favorite bourbon that I've been enjoying at home, the Blantons. And the thing I like about the Blantons is I don't know how familiar you are with the way different bourbons are prepared.
Did I just tell you I went to the University of Kentucky? I am very familiar with the way bourbons are prepared. You tour the distiller, you find out it has to be 51% corn mash and charred oak single-use barrel.
Oh, so you've toured the distillery.
Oh, yeah. I've been, not to this one particularly,
Yeah.
but yeah, I've been to some bourbon distilleries.
Well, so for our listeners who did not spend significant time, so a lot of times bourbons, they'll be blended from multiple barrels that are maybe in multiple parts of the warehouse. And the reason they do this, unsurprisingly, is to get a real consistent product from bottle to bottle.
Yeah, you need to make hundreds of millions of gallons that taste the same.
Yeah, so if you blend, 100 barrels together, all of the intricacies and idiosyncrasies of each individual barrel that was in its individual space on the warehouse rack, it's all going to kind of be diluted out.
It's just the commodification of our whiskey barrel.
But not so with Blanton's.
Oh, how did I know you were going to say that?
So Blanton's is actually called the original single barrel bourbon whiskey. There kind of is this obsession these days with single barrel, right? And so the idea of this is what you're getting in the bottle, all of it came from one barrel, okay? Now, the benefit of this is potentially increased character that you might get depending on, was it high up in the warehouse where maybe the temperature was a little warmer? Was it in the middle? Was it down low?
Did a rat live on top of it with his little family?
But there's potentially the downside, and this actually has happened to me with the Blantons. If you really love one bottle,
yeah, it's not going to be the same.
The next bottle might not be at all the same.
You're arguing against single barrel right now.
Well, that's part of the fun.
It is. Wait, are we allowed to taste this now?
Yeah, go ahead and taste it.
Cheers.
Yeah, cheers.
2 years.
What do you think?
And this is exciting because this bottle could be very different from the last one you had. So my first sip was fire, right? But that's the nature of drinking bourbon.
Sip, Dan, not guzzle.
No, nobody's guzzling. Just it runs down the back of your throat and halfway up your nose, and that's the joy of drinking bourbon. But as it soothes, I'm getting some butterscotch and it's a little bit sweet almost.
Yeah, I definitely think there's a sweetness to it. I think it's actually a fairly approachable bourbon. I don't know if this would be like my intro bourbon that I would give to someone if they're new to bourbon, but I think there's definitely a sweetness. I get a little bit of caramel, some vanilla. Definitely I don't know. To me, it's an easy drinking bourbon that's maybe one step beyond the Basil Hayden's that we had.
Yeah,
a number of
and if you
episodes
like
ago.
the sound of this, you can't have it because this barrel must be gone, right?
Well, that's true. And if anybody's paying attention, we are actually drinking from bottle number 107 that came from barrel 59 in Warehouse H.
So get to your stores right now for barrel 59 Warehouse H.
And in case you're curious too, Blanton's single barrel whiskey is aged 6 to 8 years in the barrel. So longer than our podcast.
Fantastic. Well, we'll have to stick around longer, but cheers, and here's to another 2 at least.
Yeah, 2 years. So Dan, I guess just to put you on the spot, reflecting back, what has doing this podcast meant to you over the last 2 years?
Wow. I didn't think anybody would actually listen to it, if I'm being totally honest with myself. I mean, we tossed around ideas periodically. Like, you would be dealing with students. You say, oh, they came in and they were talking about this. And we said, yeah, we had those same exact problems. And you and I would discuss it and come up with some advice, and no one would hear it. And so that was entertaining. And we said, we should just start a podcast. And I don't think we ever believed that anybody would listen to it. But we get emails all the time and tweets. And it's just incredible to me. People are listening, and they're also hearing things that are helping them, it just floors me.
Yeah, I mean, seriously, people, like when we get emails, like the one we read last week on the show, we get these tweets and emails where people say, you know what, this really helped me to get through it. I was thinking about quitting, or I was just feeling down on myself, but the discussions that were had on the podcast really helped me to boost my confidence in myself and keep going. I mean, man, that is certainly motivating to keep doing what we're doing. And that's exactly what we wanted to do, is to not let this graduate school or this training experience get you down and help you to remind yourself of really how great you are, how smart you are, and that you really can do this, and it's worth it.
It's a great time to remind everybody, if you do have a chance, write to us. We love to hear it, obviously. Leave us a review on iTunes. We read all of them, and it helps other people find the show somehow in the magical iTunes way. So if you do like it, that's a great way to support us.
That would be a great birthday gift, actually, for the Hello PhD podcast.
Awesome.
Write us a review.
We'll get to read a couple thousand reviews.
Dan, another bit of news, kind of taking care of some housekeeping here at the top of the show. We had a new Patreon patron this week.
Awesome. Who was it this week?
I wanted to thank Jada, who was generous enough to become a patron of the show.
Thanks, Jada.
And Jada is super cool. You might remember multiple episodes ago, she stood in line to send us some delicious IPAs.
And now continues to support the show. That's awesome.
Yeah, thanks, Jada. And if you would like to support the show, we would certainly appreciate it. And you can do so by going to patreon.com/HelloPhD, or you can go to our website, hellophd.com, and click on the Become a Patron button.
Okay, Josh, are you ready for Science in the News?
Bring me the news. Dan, I feel like I've handed the reins of Science in the News over to you.
Well, just this week, I've been reading a lot of news. There's a lot of news to read. But this one is
any science news?
a little bit of science news. So, Josh, are you familiar with the metric system?
Metric system? You mean like that's the stuff the Europeans use to measure things?
Yeah, that's right. Exactly. Yeah. So I think as scientists, I don't know if you're like me, but as a scientist, I have this fondness and passion for the metric system. When I was a little kid and I wasn't part of this world, I thought it was annoying that there were two systems, and I didn't like that there was a metric system at all. Once you use the metric system, I think you have to agree, so much better.
Yeah, so when you were a kid, I'm going to assume, being an American child, you thought, oh, I wish everybody would just switch over to pounds and inches.
What are these kilometers?
That makes no sense.
Exactly.
Yeah, no, I totally agree. And actually, I remember even it being explained in science class in high school, and I thought, oh, well, this metric system makes so much more sense because...
Oh, did you actually have the epiphany early?
Yeah, I did. I was like, oh, it's so nice how, these prefixes tell you exactly the relationship between one unit and another unit, and I don't know.
You're so right. I mean, it's like having something base 10. When I do any house project now, and I've got to get out the tape measure, I will dig through drawers to find the metric tape measure because I don't know 3 5/8 divided by 2. I just have no idea.
Yeah, I have to tell you, Dan, I was in Puerto Rico a couple of years ago, and I rented a car while I was there. I did quite a bit of driving around the island, And that's an interesting place because they have this mixture of both systems. And so when you're driving, the speed limits and the speedometers are all in miles per hour, but the distance measurements on the signs are all in kilometers.
It could be a little bit dangerous, right?
Well, one thing that was amazing was, you'd see on the sign, this thing is it would just say 35 kilometers away, but you're used to 35 miles away, but then you get there super fast because it's really only 35 kilometers.
Nice surprise. Yeah, that's great.
Yeah.
Okay, well, as you know, Josh, the metric system, all the units have a basis in something physical and common materials typically. So you know what happens at 0 degrees Celsius, water freezes. At 100 degrees Celsius, water boils. 0 degrees Fahrenheit, nothing happens as far as I know. 100 degrees Fahrenheit, you get a small burn, I guess.
I think it was 100 degrees Fahrenheit today, man. It was toasty out there.
I think they tried to do 100 degrees Fahrenheit on human body temperature, and they just got it wrong. I'm pretty sure that's the origin.
Think they did?
Yeah, I think that's the origin of the 100 degrees Fahrenheit. That it's actually people are 98.6, but when they were doing the calibration, I mean, the original person who came up with it.
Yeah, that would be so much more satisfying if at least it would be based on something.
But still totally irrelevant. Totally. So water is the thing we can measure.
32 to 98.6. That's
How do you calibrate your pipette men when you're in the lab, Josh?
I would always wait until the guy came by who worked for the company.
Yeah. What if you had to check whether it was way off?
Once every 5 years, we would.
Yeah, no, that's true. That's true. What if you had to check it? How would you do it?
Well, I would hope there was some kind of standard amount of volume that I could weigh on a scale.
Exactly. So you would take your pipette and dial it to something, and you figure out how many micrograms of water, milligrams,
like a milliliter of water should weigh a certain amount.
Yeah, a milliliter of water is 1 gram.
Yeah,
pretty easy. But the trouble with this type of system is what kind of water? It can't be salt water. Water has different densities at different temperatures, and so it was originally defined as.
We're talking like Dasani.
Yeah, it could be you take a bottle of Dasani back in the 1800s.
That's what I would always pull a mill of Dasani out.
Dasani is so young
compared to did Dasani exist when we were
No, it didn't.
Okay.
Who knows? But anyways, the absolute weight of the pure volume of water equal to a cube of the 100th part of a meter. So it's
LaCroix water. That's what I would.
It's bubbly. Yeah. What's the density of bubbly water? You're killing me over here.
I didn't do that.
Okay. So originally, a gram was defined as the absolute weight of a volume of pure water equal to the cube of the 100th part of a meter. So a centimeter cubed is basically a milliliter, and that is 1 gram. With me so far?
Yeah, makes sense.
And that water had to be later defined. They realized that water has different densities at different temperatures. So that had to be 4 degrees Celsius, which is the maximum density of water. But over time, you can imagine how that'd be really difficult to use as a calibration because people have water that have different impurities. So
would the elevation impact that?
I don't know. That's a fair question, and I have no idea. But what they did is they decided to turn it into a physical thing. So they created a kilogram weight. So they decided to scale it up to a kilogram. They created this physical weight that is made out of platinum and iridium. It's a cylinder, and it's called Le Grand K. It's kept in France.
So who made this?
It was done by the International Bureau of Weights and Measures. I don't know if they were the ones that made it or if they're the ones that hold it now, but that's who holds it.
Okay, so they said there's a lot of variability in the water thing, depending on the temperature, the purity of the water, so we want to make a physical object.
A physical object that would be based on that water mass measurement, but it's going to be platinum and iridium, so it's going to be this super stable weight that we can use for the rest of eternity to tell what a kilogram means.
So if you want to calibrate your pipette, you have to go to the International Bureau of Weights and Measures, check out their weight.
Carve off a little bit of it so you just get a few grams. So what they do is they use this weight as the standard for all other weights so that you can put it in a balance, I suppose. Other organizations will be able to use this to say we're basing our kilogram off of that kilogram, and then when they make balances at Fisher, that's the reference that they're using.
So in one way or another, every weight that we have,
every mass, I guess we should be
sorry,
right?
yeah, every mass that we have can eventually be traced back to this
Le Grand K.
This reference weight.
Le Grand K. Say it. No, you don't have to say it with me. So that has worked just fine, except there is a problem. and that is Le Grand K is actually losing weight.
Ooh, what's its secret?
Exactly. It's the French paradox. I have no idea. So it was
Must
made...
be a Whole30.
Yeah, could be. It's like the Atkins plus South Beach kind of thing going on.
Yeah.
When it was made in 1889, they actually forged these identically masked witness cylinders, they call them. And they were stored in labs around the world. But what they've discovered recently is that Le Grand K is 45 micrograms lighter than those once identical witness cylinders. So that's like the weight of an eyelash. And people in lab weigh things at these scales regularly. So
a question. So how do they know Le Grand K is losing weight and the witness cylinders are not gaining weight?
They don't.
But I guess they have multiple of those.
Right. Then you'd think that maybe all of them couldn't be gaining weight at the same speed, but they could be accumulating contaminants or rust or who knows what.
So, okay, so what?
So what? Yeah, like who cares, right? Well, it turns out anybody who cares about the massive things cares. The United States has a National Institute of Standards and Technologies, and that's the organization that oversees weights and measures for the U.S. And a few years ago, they had to reissue certificates for their kilograms because they were these 45 micrograms off of the French prototype. And so that means that everybody who produces weights based on that NIST standard had to reissue their own weights. And of course, that's a huge cost. They were mad about it. They called their congressman. The congressman called the NIST and said, "You're messing up. Fix this." And that's when they realized that it wasn't the NIST that had their standards off. It was actually Le Grand K. And so, who cares about 45 micrograms?
You actually see here on your notes, Dan, that 45 micrograms is about the weight of an eyelash.
Yeah.
Well, so big deal.
Yeah, it doesn't seem like a big deal, but I think, imagine you were repeating an experiment with some antibody and the mass is off by 45 micrograms in whatever the stock solution. It could make a difference. And, maybe it's not antibodies, it's something else.
Or, I'm imagining you have something that weighs not 1 kilogram, but maybe weighs 10,000 kilograms. And now you've amplified that error by 10,000 times.
Right, exactly right. And so, I think medicine, manufacturing, one of the references in the article says that the effectiveness of filters on a diesel engine is measured by the soot they capture in micrograms. So it really does. It actually makes a difference if you have a different understanding of this mass than I do. And maybe I'm trying to repeat your experiment, or I'm trying to sell you a diesel filter.
So what's going to happen now? So are they...
They're going to all switch to British pound stones.
I actually did wonder if in our American standards and measurements office, if we have a platinum and iridium pound.
I didn't look it up, but I'm sure we do. I'm sure that's the case.
Great.
So the way this is typically done in the metric system, and you'll be pleased to know this is not the first time this has happened, where we started with some physical measurement that turned into a physical object, and then we said, wait, that's not stable. So when the meter was defined in 1793 as 1/10,000,000th the distance from the equator to the North Pole, which I don't know exactly.
I did not realize that's where the meter came from.
It's a very long meter stick. In 1799, it was redefined in terms of a prototype meter bar, and that was used for a while. And then in 1960, the meter was redefined in terms of a certain number of wavelengths of a certain emission line of krypton 86. So now we're moving to a wavelength, which we believe is much more standard over time and place, and could be measured in outer space or here or wherever. So the meter now has a definition that we should all agree on and shouldn't change. So what are they going to use for mass? Well, it turns out that you can take something called the Planck constant, and some of the units of that can be turned into kilograms if you do it the exact right way. And I'm not going to claim to have any background or knowledge of how you derive the Planck constant, but maybe you've heard of it. And what they're trying to do, what the scientists are trying to do at the NIST, is to measure it so precisely that they can use that as the final kind of abstract definition of a kilogram. And they're using something called a Kibble balance, which instead of using weights to balance like you would on a triple beam balance or something like that, it uses electromagnetic coils that they can determine the precise force of, and then use that to determine what a kilogram is.
Yeah, I kind of like that. So instead of relying on this tangible physical object to determine this. We're going to instead base it off of some property that we could at any time measure.
Yeah, and the background of this is in quantum physics, and I won't pretend to understand it, but after 16 months worth of measurements, they calculated the Planck constant to be 6.626069934 times 10 to the minus 34th kilogram meters squared per second.
Great.
You enjoying that one? Yeah.
Yeah.
And the really important part is not just how great that number is and how precise it is, but it's also the uncertainty is very low. So just 13 parts per billion. And that is beyond the threshold that the NIST wanted to actually change the standard. So it looks like it's up for review soon, and they'll decide whether this becomes the new kilogram.
What a job to have.
Exactly. Don't miss a decimal place.
What a time to be alive, Dan.
I agree with you, Josh. And that was Science in the News.
All right, Dan, it's fitting that on our 2-year anniversary that we answer a listener email.
We should do it every week. All right, Josh, I'll do the honors. Hi, Josh and Dan. That's us.
That's us.
I recently found your podcast and am really enjoying it. I am planning to apply to social psychology PhD programs later this year to hopefully start in the fall. And I'm already taking notes as I listen to you guys.
I hope you're taking notes on the best beers to drink.
And bourbons.
And bourbons.
Yep. Specifically, I really liked your episodes on taking time for kids and not being too old to go back to school, as I'm over 30 and have a 1.5-year-old. That's totally fine, right? Answer, yes, it is totally fine.
Fine and stressful, but fine.
Yeah, that's right. It doesn't make it easy. It just makes it fine.
True story. We had to stop the recording just a second ago because Dan's wife texted because he has a screaming 1-year-old at home.
He's teething. It's not great.
Yeah. So yeah, totally fine.
This
totally
too shall pass. Yeah.
Okay.
You convinced me, Josh, that it all gets better.
It gets better.
Okay. Reading on. Anyway, my question is, how specific do your research interests need to be when applying? Also, how closely do your research interests need to align with potential faculty advisors? I realize that social psychology programs are probably quite different from the harder sciences, and that's in quotes.
Her words,
air
not
quotes,
ours.
harder science. Yeah, we would never say that. But I assume that this issue spans across all fields. I'm worried that if I'm too specific, I'll box myself out from potential advisors. But I also don't want to be too general and appear unfocused. Do you have any tips? Thanks again, April.
All right, April. Thanks for that email.
That does sound like a problem that crosses boundaries. I remember struggling with that myself as I was applying to schools.
Yeah, no, that's a great question. So I have some thoughts on this, Dan. So it sounds like her questions were, to what degree do your research interests when you're applying for grad school, how specific do they need to be? How well defined?
Yeah, how well do you need to be able to articulate them and write them down on paper and to say, I want to research this protein in whatever.
Yeah, and let's address that part first. So I do have some thoughts on this, and I think there's two sides of this coin. First of all, and this kind of is a little bit of a tangent off of her question, but we've talked about this before, beyond just what are my interests, but thinking about what do I want to do? What are my goals? I'm thinking about graduate school. Is graduate school the right next step for me, depending on
based on,
do
I want to have a faculty career, or do I want to work in industry, or do I want to be maybe she wants to be a social worker or a social psychologist or something else, and this is not the right program.
Yeah, and I'll say this too. As I was saying that, I was thinking about my own experience, and I don't know that I could have articulated at the time I applied to graduate school exactly what type of career I wanted. I think what I knew
to be a dentist.
That was after my first year of graduate school.
That's right, yeah.
I think what I knew at the time that I applied to grad school was I had found research, and I just really loved doing research. And I thought, okay, grad school is the right thing for me to do, because right now I just want to do more of this. I just want to work in the lab and research, and grad school is an opportunity to become a better researcher, to learn more about being a scientist. And I don't know that I necessarily at that time was thinking about it like, oh, this is the step I need to take to get to this career. It was more, wow, this is what I really love to do right now. And so this seems to be the next logical step, so I can continue doing that.
Yeah, and I would say that for me, I wish I had done more of a gut check or an understanding very early on. I was ambivalent too. I couldn't quite decide which research program I wanted to be in. I applied to some microbiology things, but the thing that fascinated me about microbiology was the way that these microorganisms took over the host cells and used them for their purposes. I would have been much better off and much happier in a more applied science field. So if I were maybe in bioengineering, or if I had just gone straight to industry, I probably would have been much happier. But I didn't recognize that at the time. I looked out at the group of fields and I thought, well, I'm not totally passionate about any of the research that these people are describing, so maybe I'll just try this one.
It's ironic, Dan, the thing you described that you were interested in when you came into grad school is very similar to what I ended up studying in graduate school and in my postdoc.
Had I known,
you should have ended up in the micro department with me.
Would have been great.
I know. So anyway, that aside, let's assume that you've decided, grad school is definitely the step that I want to take, the step I need to take right now. And I assume that's the boat April's in, based on her email.
Yeah. She has a section later on where she describes the specific field she's interested in studying, but she says there doesn't appear to be much research in this specific area within the social psychology world. So the thing that she says she wants to do may not be really well represented.
Yeah, there's kind of two ways to look at how specific your interests need to be when you apply. And on one hand, it depends what type of program you're applying to. So I'm going to speak briefly about what I know of the biomedical research world, but I think this could apply to other fields as well. So, at least in our world, there are two main genres of program. There are these programs like the ones we entered, Dan, these umbrella admissions programs. And so what these tend to do is a lot of times there will be, instead of applying to a single department with a specific focus, these umbrella programs often will bring in multiple departments or multiple fields that maybe are related under some umbrella, like biomedical science. But once you get into the program, you can actually shop around for different faculty who are doing lots of different things. So some of your classmates, they might not all be microbiologists, but there might be some neuroscientists and some cell biologists, some computational biologists. And so in a program like that, clearly it's not going to be important that you say, I am 100% interested in this specific topic, because the nature of the program is by nature very open.
Yeah, and even if the individual school doesn't have this umbrella program that's very broad and diverse, a lot of times there will be collaborations among either nearby or even distant universities where students work the first few years at one university and then transfer to a lab at another university where they collaborate. So there are ways maybe to get some diversity in your experience, even if that program doesn't have a wide group of faculty interests.
I think another reason why your research interest doesn't have to be completely crystallized and defined is if you're coming into graduate school, let's just presume for a second that primarily your research interest has been formed based on your experiences as an undergraduate. For the most part, the research opportunities that you're presented as an undergrad can be very limited and very based on circumstance. So the research that you've been exposed to as an undergrad depends on who at my institution just happened to have an opening.
Yeah, that is totally my experience. I got interested in toxoplasma because I was in, I guess, my junior year of college, and somebody let me work in their toxoplasma lab. If I had worked somewhere else, maybe it would have been a different experience.
Yeah, that was totally my story too. I, decided, I was recommended, like, hey, have you thought about research by my advisor? I was like, no, I hadn't thought about that. Can I work with you? And she was like, well, no, you can't work with me, but here's this new microbiologist guy. You can work with him. And it had a lot more to do with that was an opportunity that was available compared to me as a 19-year-old saying, I'm really interested in bacterial pathogenesis.
Yeah, you were so interested in that. My advice in cases where maybe you haven't explored the full field of experience, I tend to send people two places. Look at the websites and journals and any kind of media that you already consume. So if you're scrolling through CNN and there's like one of those puff pieces about science, and there's a certain theme that you always click on, it's something about social psychology or a certain field of social psychology, and you say, I have to read that one. That's the one that's for me. I have a certain genre that I click on all the time. I just read something about them making spider silk out of some weird protein mash. I pass over hundreds of articles about other things, but I see something like that and I have to click on it. If you have things like that, kind of take a mental note of those. Pick up a handful of journals from different genres. Scroll through the table of contents. If you see 4 articles in one journal that look interesting that you'd like to maybe read, it's a good sign that it's something you want. And then my last piece is talk with faculty. They love to talk about what they do. You don't have to commit 4 or 5 years or 6 years to have a conversation, and you'll get a sense of certainly they're excited about it, they're passionate about it, but you'll get a sense of, are you gnawing your arm off to get out of the conversation, or does it make you think of 14 next steps that you could take on this particular field that would be so exciting to work on? And it would just expose you. I think you have to force yourself out of your comfort zone a little bit to just sample the field and find out what's out there.
Yeah, that is definitely true. And sometimes faculty have a lot of interests that go beyond just maybe what's on their website and what they've already published. So I think if you can...
That's what got funded, right?
Yeah,
not
right,
necessarily what they're totally passionate about.
Or what they have been doing, right? I mean, that's one of the beauties of being a faculty member is a lot of times you can reinvent yourself or study new things depending on new ideas you have or new people you come across. So if you find people who are doing similar things or related things, certainly it's okay to be very open about what your interests are, and maybe they'll have some ideas or ways that they could maybe implement that in their own lab.
Yeah, I think it's a pretty straightforward email, and it just says, hey, I'm exploring the options available in the field of whatever. Would you be willing to talk to me about what are the current research projects in your lab, but also what's happening in the field that you think is interesting? And I don't know, very few people, unless they're on vacation, are going to say no to that.
Yeah, so on one hand, you don't necessarily need to feel like you have to completely have nailed down exactly your research area when you apply to graduate school, because perhaps the experiences you've had are based on a limited set of opportunities you've had in your past. And actually in grad school, you might have the opportunity to be exposed to different things you haven't even thought about before. So often also recommend students who enter grad school to enter with an open mind, because you may encounter something that really is cool that you hadn't considered before. But definitely do what Dan said and pay attention to that feeling in your gut or in your brain when...
In your right elbow, that feeling right over there.
You hear that one faculty member talk, or you have that one conversation, you're like, oh my gosh, that's really interesting. That made me think. That made me really excited. That gave me energy. So pay attention to that. But on the other hand, April asks, how closely do your research interests need to align with potential faculty advisors? So that being said, what you don't want to do, though, is, let's say you're thinking about applying to a certain school, and April mentioned she was interested in social psychology. So she goes to the psychology department website and looks at their faculty list and skims their research interests. What you want to be careful about is not applying to a program where there are no faculty or very few faculty doing anything even remotely related to what you're interested in, because that's kind of a recipe for disaster. And while I would say April probably, and no one would probably apply for a grad program they're not interested in any faculty, but I have seen students who will go to a university because they really want to work with Professor X.
Who doesn't? You'd have superpowers.
That's right. Is that the X-Man guy?
Yeah.
But here's the thing. Let's say you come to the...
He taught me telepathy.
Who wouldn't want to work with, what's his name? What's that guy who played him? Star Trek
Patrick
guy.
Stewart.
Patrick Stewart, yeah. Who wouldn't want to work with him?
Of course.
But let's say, you go to work with Professor X, and then you get there on the first day and you go to Professor X's office and realize, oh, Professor X took another job at the university across the country.
Or he's a sociopath, which happens,
or he's really a jerk. And
then you're stuck in the place where not only is it difficult to change labs, if you're early on, it's okay, but it's tough to do. If you have to change universities, you have to, break your apartment lease. If you have to, all this stuff, it's just infinitely harder. And I think we have seen people that say, I only applied to this school because of Professor X, and I don't even care about this program, but I want to work in this lab. That's a very, very dangerous gamble.
Yeah, I think in general, especially if it's the type of program, if it's a type of graduate program where you have options to work with different faculty. Now, I will admit there could be other types of graduate programs out there that still follow the model where you have to be matched up with an advisor before you start. And so if your type of program is like that, the rules are probably different. But in our world, typically the way these work is you come in and you can rotate through or talk to different faculty before you choose a thesis advisor. In programs like that, you want to make sure there are at least several And by several, I would say at least 3 faculty that you could at least imagine, all right, what they do is interesting to me.
Yeah. I mean, we've covered this on the show. People write in and they say, I love my lab, I love my research, but there's this postdoc that drives me insane, right? There are so many factors that could make an individual lab a bad choice. And so if you have the chance to rotate, do it. And if you have the chance to choose a school with multiple options, that is a good place to go. So Josh, I just want to add one more thing. I think we get a little bit wrapped around the axle when we're looking at grad school and we're saying, well, I have to choose the exact right mentor now because I'm going to spend the next 50 years of my life studying toxoplasma. Guess what? No, you won't. There are so many opportunities after your graduate training to wildly change your research interest. Now, you may not jump into you may not go to, English literature after this, but if you are in graduate school, you are publishing, you are learning the scientific method, if you are meeting people, I think you have a really good opportunity after graduate school, if you need to do a postdoc, to change then, or even to change later on to define your own path after graduate school.
I absolutely agree, Dan. And because of that, I feel like we say this a lot, but I really believe it, choosing a mentor, not just choosing who's going to be a good research advisor, who's doing work that I think is really cool, but on top of that, who's somebody that I feel like is really going to help me grow as a scientist, grow as a researcher, and really help me get to where I want to be when I'm ready to graduate and move on to the thing that I'm actually going to do with my life.
Yeah, you're there for training first and foremost, and so that really counts for a lot. If you come out with your degree, but your mental health has suffered, and your confidence is down, and you are the world's expert in this particular thing, but you don't really care about working on it anymore, but now you don't have the wherewithal to go do something else because you just feel terrible. Not worth it.
Yeah, I mean, I would much rather see someone come out of graduate school loving science, feeling extremely confident about their abilities as
motivated.
A researcher, and with a good knowledge of, all right, based on these experiences I had, now I have this really good feeling of this is where I want to go. This is what I want to do now that I have this independence and I've got this confidence, and you launch out into that at that moment versus coming into graduate school as a fledgling researcher, chasing the really sexy research, but ignoring some really blatant red flags about the person that's going to be your advisor. Chances are, and we've seen this happen, Dan, you're not going to stick in research for a long time. You're going to get burned out, chewed up, and you might leave and do something else.
Yeah, that thing you think you love now, you might learn to hate if it gets ruined for you. So while you're in graduate school, let's say you take a position with a researcher that maybe not precisely what you want to do, but it's pretty good. You're interested in it. You can go to work every day, make progress. I think in graduate school is the time to start preparing for that next step. So make sure you're attending conferences where you might meet the people who are doing the type of research you want to do. Now, she mentioned that the field she's interested in may not have a lot of representation, but I'll bet you there's somebody out there working on it. Find out what meetings they go to. Even if you can't go to graduate school in that area, there are ways to meet those people. Start a journal club. Subscribe to a journal that covers the topic you're interested in. Become an expert. You don't need to have a degree and a paper in that thing to be an expert in it. You can be part of the conversation. And again, get on Twitter, get on email, meet people, meet faculty members who are researching these things. If your field that you want to do doesn't exist, start to create it, which is, you're in grad school. This is the perfect time. You've got a type of freedom in grad school that you may never have again. So start now.
Yeah, and I'll say if it is a specific field or thing you're interested in and you happen to come across the name of someone doing similar work, don't be shy. Reach out to them, because the thing I know about most academics is the thing they love the most is when someone else appreciates and is interested in what they're interested in. So be bold and feel free to reach out to them, even if they're across the world or across the country or whatever.
You found collaborators on Twitter.
Yeah, a collaborator found me on Twitter. And actually, we had a phone call this week and are going to start a collaboration because he tweeted at me.
And you didn't say, no, you're not at my university. I'll never speak to people that are outside.
That's right. You did not leave me a voicemail.
Yeah.
Actually, if you left me a voicemail, I would have never got it because I don't answer my voicemail.
You didn't mail me reprints in a manila envelope.
That's right.
I refuse to speak to you.
That's right. So anyway, April, I hope this was helpful. Good luck to you applying to graduate school.
Yeah, let us know how it goes for sure.
Definitely. And as long as you have a Hello PhD at your side, you can accomplish anything.
Yeah, share it with your graduate program. I know that we are not specifically for social psychologists, but I think some of the experiences are the same. And let us know what those experiences are. Maybe we can have you on the show.
That's right. All right, Dan, you have a word puzzle for us this week?
I do. A word puzzle and a scary picture for you, Josh.
Oh, my goodness.
The clue last week was, if you spot a snake with twisted colors, walk the other way. Its fishhook teeth are venomous.
Okay, so on the show notes, there's this scary-looking snake with his fangs sticking out at me. It kind of startled me.
Kind of fishhook shaped, right?
I hate snakes, Dan. I hate them.
Okay, so I will just give you the answer, Josh. It is actually the copperhead snake. And copperhead's actual genus and species are Agkistrodon contortrix. Named by Carolus Linnaeus in 1766. This one's kind of fun. Have you seen a copperhead around here?
Yeah, I've almost stepped on one before.
Yeah, the reason this came up in the show notes this week is because I have a friend whose son got bit by one, and they didn't give him antivenom, but they put him on morphine, I think, which is quite frightening. But he could barely walk for a little while. They're terrible little snakes.
As far as venomous snakes go, they're less deadly, less poisonous than some, but it's still no fun to get, especially if you're a kid.
I think that's right. They're a little bit less deadly, but they're more likely to bite. And,
yes.
So kind of a nasty little creature. But I guess they serve a purpose in the ecosystem. So Agkistrodon comes from ankistron, which is Greek, meaning fish hook. And I think you can see his teeth are sort of hook-shaped.
Yeah.
So the ankistro is fish hook, and there's odon, which is teeth. And then contortrix, meaning comes from contortus, which is twisted, intricate, complex. And if you see the pattern of a copperhead, you'll notice that shape. So when you see it, walk the other way. Most people get bitten by trying to kill it or chase it or do things to it.
Yeah, I did read
They
that.
don't want to hurt you. Just get away.
Yeah, I think I read some stats on snake bites once, and it said there's a disproportionately large number of males under 30 who get bitten by venomous snakes.
Yeah, they think, I'm going to take this thing out, and they get a shovel, and then they get right.
Yeah.
Bad idea. Leave it alone. It's probably catching mice in your yard or something. Okay, so Josh, are you ready for next week's clue?
I'm ready.
Slightly less frightening. This hardened substance has allowed ancient and modern cities to grow together in travel and trade. I'll read it one more time. This hardened substance has allowed ancient and modern cities to grow together in travel and trade. Remember, I'm looking for a scientific word described by the clue, and once you get it, you'll find the literal meaning of that science word as a phrase in the clue itself. If you think you know the answer, email it to puzzle@hellophd.com. We'll randomly select a winner from all the correct answers and send the lucky puzzler an Amazon gift card.
All right, Dan, thanks for that. So as I mentioned, we love to get feedback, and we love to hear from you, our listeners. If you've got a question or topic idea, we would love to hear it. Email us at podcast@hellophd.com, send us a tweet at hellophd, or leave us a message on the Facebook page. If you like the show, leave us a review on iTunes. We love the feedback, and it helps new listeners find the show. If you'd like to support the show, you can become a patron. Simply go to our website, hellophd.com, and click on the Become a Patron button, or you can visit patreon.com/hellophd. We'd appreciate the beer money.
And bourbon money.
There you go. And thanks to our current patrons, Lynn, Arlen, Paul, Rob, and now Jada. We love you guys. Cheers to you.
And happy birthday.
Happy birthday, and let's hope for 2 more, Dan.
All right, at least two.
All right, good night.